already never before. Okay, good afternoon, ladies and gentlemen. As they have already said, my name is Mr. Mokgokong, but you can call me Taranelo. Taranelo.
Comrade.
Oh, you can call me Comrade? Yeah? Yeah, so I'll be presenting the progress of my research. Can we go to the next slide? So the aim is to try and develop a predictive model for supply chain, for managing supply chain risk in a rail manufacturing sector. So I think colleagues, some of you have already had words like agile manufacturing. I heard they were talking about supplier development, and also there's a new term now called supply chain visibility. So you ask yourself, what are those terms and what are they for? So what are they trying to do? So they are trying to make sure that the supply chain achieves the intended outcome. So they are trying to do what? To manage the supply chain risks that are within their supply chain network. So if you look at the diagram here, for the past 10 years, you can see how the definition of supply chain risk has evolved over time. And you can say even now, in 2021, supply chain risk can be defined differently to how it was defined in 2019. Because now we are looking at how do we harness technology to ensure that the processes achieve whatever they need to achieve. Can you go to the next slide? So, okay, so if you look at the global scale of where South Africa fits in the entire rail industry, if you look at the rail industry, the way it is dominated by players from China, you have other players from Australia, then you have players from India and the Americans and some in Europe. So if you look at the types of challenges or risks that are faced by rolling stock manufacturers globally, you can see they are categorized as external and internal. So we are going to be concentrating on supplier capacity, which has been spoken about already, and also we're going to look at component failure, because these are risks that are all in all these other domains that I've already mentioned. So if you can look at the company that we are talking about now, that we are, I don't want to mention otherwise, but it's fine. So if you look at the OTIF from 2019 to 80s, OTIF, I think my colleague have already mentioned what it is, and also they spoke about NCR. You can see as the demand goes up, NCRs are going up, which is a natural variation that is there within processes. The more you produce, there are more chances where you're going to be producing parts that are not conforming to the requirement. So as you can see, there's actually a gap there, because based on international standards, we need an OTIF of 90 plus to reach your objective. As you can see where company X is at 66%. So you can see there's roughly between 20 and 35% of activities that needs to be done to ensure that you move all your suppliers to where they need to be. So the aim of the project as a whole is to develop a predictive model to manage the supply chain risk, as I mentioned. So those are our objectives. We want to establish the risks that are found there in the rail sector, whether locally, globally, and also identify and assess the root causes of that, establish a model, and now develop a tool that industry can use to manage the risks that are there. So the methodology that we are going to use in the project is a hybrid supply chain modeling, where we are using a combination of multi-agent based model and also a discrete model. So what will happen here is you will have 3 different types of agent. You will have an OE agent, you have a supply agent, you have a track agent. So they will together interact with the discrete model. So the ordering will take place based on the inventory policy that the particular company has, and then from there it will be processed by the supplier. And whether the supplier owns the transportation or not is actually not irrelevant at this point. So you have the truck, then it delivers. So what's important for us, I think, what is important is this order processing time, because the order processing time will determine if the supplier will meet the demand that comes from the customer. So obviously, based on the demand, we can determine what is the production rate that the supplier needs to be at to meet the particular demand. So this is for us, this is where we are now. We are trying to determine that to say, based on the demand, at which level must the supplier be to ensure that the demand is being met. So also what we have developed as part of the study, we've developed a hybrid risk assessment framework model for the rail sector, and we did a trial for this at Transnet Engineering. So to find out what are how do we make sure that rail industry, as an industry, have the tools and the capacities to solve and analyze their own problems. If, for example, you have an OE that doesn't have the capacity to do supplier development, how do we empower that particular supplier to solve their own problems? So this is a tool that we have developed and we tested at Transnet. So obviously, as we test, we will modify as we go, but this is one of the outputs of the study. Can we move to the next? So if you look at the supplier we are talking about, if you look at the first graph, you look at the Pareto where you see which part contributes to the number of non-conformance that are there. So we did two Paretos. We did one at the component level to see which components are giving problems, and also we did another one on the supply level. So you see the one in red is the supplier. So if you look at those two suppliers, they contribute 60% of the problem. But if you look at the components there, this is where the study is, where the conceptualizing stage. So we are trying to decide, are we looking at the suppliers as a whole, or are we looking at different components? And also keep in mind, we need to achieve 60% plus of local content, which speaks to what the colleagues were talking about. And also, if we go further into analysis, to say this is a component, this is the supplier, but now when we look at to a material level, if we look at the material level to say, what sort of material is giving us problems? You see, can you go to the next slide? So you can see that composites are the one that gives a lot of problems in terms of the NCR that were shown in the first graph. And also, if you look at inside the train, 80% of those components that you can see are composites. You look at the face of the train are composites. So the idea now is it worthwhile for us to look at it at a supply level, or to look at it at a component level, or to look at it at a material level? So as I've alluded earlier, we have 3 agents, we have four different agents. So on the other side is the rules that govern the agent, how they interact with the OE based on the policies of ordering and how the thing is to be delivered. So what we have done so far, we said, okay, it's fine. Since we're in a conceptual model, how can we now model the 2 different scenarios? So now, like my colleague was presenting, she was talking about complicated parts, where you have your underframes, your braking system, and whatever. So the question that we are trying to answer is, for us, if we use OTIF as a measure, is it good enough for us to achieve what we want to achieve, which is the final assembly of that particular part? So for example, if you have 5 suppliers here at 90%, or 3 suppliers here at 40%, are you still going to be able to achieve the sub-assembly that we need to do? So that's the first model we ran to say, let's look at it at the assembly level to say, these are the components at the supply level. Obviously, each component is connected to a particular supply. Is it worthwhile for us to look at it then? Then now we are like, okay, can we now look at a composite level to say, can we get all our composite suppliers to be compliant so that we can be able to achieve what we want to achieve? Because remember, we solve this problem, 60% of our problem goes away, and 80% of the interior of the train is available, and we can meet the target that we set up for ourselves. So the expected results after we have done, so now here we just ran one simulation based on the suppliers. So what we're looking at, what we want to attain at the end of the day is, when you run the model for a particular part, based on different components that constitute that part, and also based on different suppliers that supply that part, we need to know, based on the processing time, based on the delivery rate, and based on how we consume from our stock, then we should be able, the model should be able to tell you that if you continue operating the way we are continuing, you're going to run short of part B, you're going to run short of part C, and then from there it can actually highlight to you to say, these are the parts that you need to look at that particular supplier. Okay, so in conclusion, what we are saying is, for us, modeling will play a very important role going forward for OEs in the rail sector, in determining or in how they should manage their supply chain, and also how should they manage the production within their floor. And also, so these are the activities that we still going to take. So these are some of the significance of the study, why we are doing the study, and how the study is important in the bigger scheme of things. And so industrial business case, so as I've alluded, after we've developed the model, the framework, we tested it at Transnet, and it's something that we can actually offer to the rail sector to say, for you to be self-sustainable, you can get trained on this tool and actually get certificated by the University of Technology. So we are not only offering it to the company, it's also something that the company can use to encourage their employees to say, when you go for this training, you can go and get a certificate from the University of Technology. And also, as we are doing the study, as we receive the data, there are methods that now we are using to analyze the data. And from there, we're going to develop another short learning program where we can train them to say, when you have the data, this is how you cluster it, this is how you clean it up, this is how you do statistical analysis, and all of that and all of that. So I think this is the end of my presentation. I like to appreciate the university and also the developer for all the opportunities that they are affording to us. Thank you very much.